Alright, Bismillah, Assalamu alaikum. So today we'll be doing what's called balancing redox reactions, and in this case under acidic conditions, and we'll be using the method called the half reactions method. So suppose we're given this equation, this reaction, Cr2O7 negative reacting with chloride to give you Cr3 plus and Cl2 gas. Okay, so the first thing we have to do in this sort of problems is to break up the reaction into half reactions. So we assume that this whole reaction is made up of two separate reactions, and of course this doesn't happen in real life. In real life it's just one reaction, but on paper we'll treat them as two separate reactions, and that's this method, half reaction method. So let's do with Cr2O7 2 negative giving you Cr3 plus. That's one, and the other one would be the Cl negative giving you Cl2, right? Okay, once you've done that, and then we'll go ahead and solve and try to balance them, and then at the end we'll combine them. So we'll do that right now. All right, so let's go with the first reaction, which is Cr2O7 2 negative giving you Cr3 plus. So the rule that we have to follow is as follows. Okay, so these half reaction methods are done by following these rules, and the rules are this, right? So first thing we have to do is we balance all the atoms other than hydrogen and oxygen, and then we go balance oxygen, then hydrogen, and then we balance the electrons. So let's see what do we have to balance other than oxygen here. We notice there are two chromium here, so we have to go and we added 2 here. So that chromium is balanced. Then we look at the oxygen. Now the oxygen has 7 oxygen here, and how do we go about balancing the oxygens? So the way we balance oxygen is by adding water, right? So we're going to add plus H2O, water. But how many do we need? We have got 7 oxygen here, right? So we've got 7 oxygen here. It's only 1 here. There's only 1 here. So we have to add S7 there. So the oxygens are balanced. Then we have to balance the hydrogen, right? So balance the oxygen, then the hydrogen. And of course the hydrogens are balanced by adding H plus. So we're going to make it a little bit small here, and we're going to balance the hydrogen by adding H plus. So we add H plus on this side. And of course if you look at how many do we need, I've got 7 water, so 2 times 7 is 14 H plus. So I have to come back here and we have to add 14 H plus. So that balances this equation. And then we look at the charges. So how many charges do I have? Well, if you look on this side, I've got 14 FH plus and 2 negative, right? So I've got 14 positives and I've got 2 negative on this side. If you look at on this side, I've got 2 times 3, 6. I've got 6 positive here only. So the net, if you do that, I've got 12 plus here, right? And if you look at on the other side, I've got 6. So that's, sorry, so it's giving you on this side 6 positive. So we have to balance, we have to make sure that these are balanced, and they are not. I've got 12 on this side and 6 on this side, and we balance electrons by adding balance the charges by adding electrons. So I have to add electrons, I have to add negative parts to the side that has more positive. So here I've got 12, I must make them somehow equal to 6, and the way we do it, we can add 6 electrons on this side. So 6 negative plus 12 positive will give you 6 positive. So this has to go on this side. So on this side we add 6 electrons. All right. So that would make this equation, that would make now this half of the equation as a fully balanced half reaction. So now we look at the other half of the reaction, which was Cl negative giving you Cl2 gas, right? So same thing here, we look at the rules, and the rule says we balance other atoms other than oxygen and hydrogen, right? So we go here and we're gonna add, we have, and if you look on this side, on the left hand side, on the right hand side, I've got 2 Cl, I've got only 1 here, so of course I must add a 2 on this side, so that's balance. There are no oxygens here, so nothing to balance. There are no hydrogens here, and nothing's to balance. But if you look at the charges here, on this side I've got 2 negative, now on this side I've got 0. How do I make them equal? Right? Again, same thing, we look at the, we balance the charges by adding electrons. So look at the side that has a higher number, higher positive value, which is in this case this side. So I have to add 2 electrons on this side, right, to make them equal to -2. So I'm going to add 2 electrons on this side, right? So now that makes that balanced half reaction as well. So this is balanced as well, and then we combine them, right? So if we come, all right, so now we look at the two half reactions which we have just made, and the first one was this one done on the top, and we just did this just now. So the next step is to combine them together, but before we combine them, a few things to note here, right? This is a redox reaction, so it's reduction oxidation. That means something must be getting oxidized, something else must be getting reduced. So if you look at the two half reactions, the way we make sure that we've done it properly, that one half reaction needs the electrons, right? It's plus electrons on the left hand side, and the other one should have the electron on the right hand side. So this guy is producing the electrons, which are then taken up by this half reaction. So make sure that the electrons are on opposite ends, right? Opposite halves. Okay. The other thing, we have to make sure that we have 6 electrons here that are needed, but you're only producing 2 here. So we have to balance this as well. And so the way we do it, again, we want to make sure again that these 6 is equal to this number, and they're not. So what we do, we multiply this half reaction by a number, in this case 3. So 3 times 2 would be 6. So this becomes 6 Cl minus, giving you 3 Cl2 plus 6 electrons. So now this number matches this, and then we combine the top and the bottom. So we combine this guy here and we combine this guy together, right? So we can write, so basically the way we do it, we write 14H plus Cr2O7 2 negative plus 6 electrons, right? So we write all of these guys here, and we write this one here as well, because we're adding up all of this, right? And then we're going to add up all of them. So we add up all of this now, right? So plus, we go 6 Cl minus, which is this guy here. Okay, now this would be giving us, now we go and look at the right hand side, all of this and all of that. Okay, so it's giving us 2 Cr3 plus 7 H2O plus, again, all of these guys here, plus 3 Cl2 plus 6 electrons. Okay, now then once you've combined them together, the two half reactions are combined now. See what you can cancel on both sides. If you look here, the electrons, 6 electrons on this and 6 on this, they can easily be cancelled, so we can remove that and remove, right? And that basically gives the whole net reaction as 14H plus Cr2O7 2 negative plus 6 Cl minus, right? Okay, giving you 2 Cr3 plus 7 H2O plus 3 Cl2, and that is how we balance the half reaction using the half reaction method. All right.